Hello, Sauce here. I'm going to show you how to solve a system by substitution. I've written a system on my paper. Negative 8x plus 6y is equal to negative 4. And a second equation, y is equal to 2x. This is a system because it has more than one equation that I have to consider. And if I'm going to solve it, I need a value for all of the variables and all of the equations that make all of the equations true. That means that I need to find a value for x and y. And if I substitute those values in for x and y, then it would show that this equation is true, and with those same values, this equation is true also. Now, we had a lesson on solving a system by graphing. We could do that. These are equations that can be graphed, and their solutions are going to be the coordinates, the x and y values, where these two equations cross each other. And there might be more than one solution if we see that the equations cross in more than one place. But I'm going to solve the system algebraically by a very common technique called substitution that we've done many times in the past, but this time we're going to apply it to this kind of problem. What that means is I'm going to observe that y is equal to 2x. This is a simple equation because the variable y is solved for and we know what it's equal to. So if I rewrite this first equation, but when rewriting it, I substitute 2x in for y, then something is going to happen that allows me to move forward. So I'm going to rewrite the first equation. But when I get to y, rather than writing y, I'm going to write what y is equal to. Y is equal to 2x. And I continue to finish the rewrite. Look what I have. After the substitution, I have an equation with just x in it. So I can use the algebraic process to solve for x. And when I do, I'm going to find its value. Next line of work, negative 8x. I'm going to distribute the 6 times the 2x, which makes it 12x. And this is still equal to negative 4. I can see that I have two like terms. Negative 8x and 12x can be combined. And when they do, I have 4x. Still equal to negative 4. And remember, I'm trying to solve for x, so I want to get x by itself. I'm going to undo multiplying by 4 by dividing by 4. And what I do to one side, I must do to the other. These will cancel out, leaving x by itself. And negative 4 divided by 4 can be simplified to be negative 1. I've found a value for x. That's an important piece. I'm going to circle it. But I'm not finished because I'm solving a system that has more than one variable. So I need to finish up and solve for the other variable y. How am I going to do that? I'm going to take advantage of the fact that I have the value for x already, and I'm going to substitute this x value into the second equation and rewrite it. Rewriting the second equation as y is equal to 2, but instead of writing x, I'm going to write what x is equal to, and I know that it's negative 1. Now I'm going to continue to simplify. This is already solved for y, but I'm going to simplify the other side. 2 times negative 1 is negative 2. And here I have a value for y. I'm going to circle it. I've found values for all of my variables. There were 2, x and y, and I can express the solution as an ordered pair, a typical point where the x comes first and the y comes second in parentheses. This, if graphed, would be the coordinates of the point where the graphs of my equations cross each other or intersect. I'm going to take one more step and show you how to check that this solution to the system works. So this is a check step. I'm checking my answer. And the way I'm going to do that is if I'm confident that I have values for all of my variables, in this case x and y, then I should be able to substitute them into any one of these two equations and see that it makes the equation true. What does that mean? Well, let's see it done. I'm going to rewrite the first equation, but instead of x, I'm going to write what x is equal to, -1. And then when I get to y, I'm going to substitute what I found y to be, -2. So if I'm correct in my solution, then substituting in for x and y should make this equation true. I'm going to continue to do the math and see if that's the case. -8 times -1 is a +8. 6 times -2 is a -12. A little more work to do. I've got to combine the 8 and the -12. They make -4. And on the other side, I have a -4. I've confirmed that my solution for these variables make this equation true. -4 is equal to -4 is a truth. This is the check step that confirms my solution worked and is correct.